Good morning. Welcome to the University of Montana. So this is our 12th annual Clean Air and Healthy Homes Program Symposium. And we are so excited that you guys made it to the University of Montana today. To give us the official welcome to the University of Montana, I'd like to introduce Dr. Royce Engstrom, the President of the University of Montana.
Thanks, Tony. Good morning. Good morning. Boy, what a great turnout for this thing. I think there are about 175 according to what you told me. That's wonderful. Well, welcome to the University of Montana. We're so glad to have you on our campus today for this symposium. We had our commencement just last Saturday, and we do commencement out in the Washington Grizzly Stadium, so it's outdoors, and so we always are praying for nice sunny weather and all of that. And on Saturday, it was a pretty nice day, except the wind was really howling, so everybody's hats were tumbling across the stadium, and the diploma cases were blowing across the stage and so on. But it was a day to remember. We had a wonderful time. How many of you are seniors? Quite a few, right? Well, not so many. How many juniors? How many sophomores? And freshmen? Okay. Anybody before freshmen? A couple even before freshmen. Well, good. So, leading up to commencement, I want to tell you a couple of things, a couple of stories, because just about every day for the last several weeks leading up to commencement, we've had some kind of a celebration of student accomplishment. So Friday, for example, we recognized about 200 graduating seniors who had gone on to do really special projects or take on leadership roles. We had a few weeks ago an undergraduate research symposium where, just like you're going to be doing here, our students talked about the research projects they do or that they've worked on with other students here. And it's been such a wonderful time to see the accomplishments of those students. And they're people who just a few years ago were kind of in the same situation you were, taking on special projects in high school, doing research and so on. So I want to tell you kind of a personal story. I have the privilege of being the president of the University of Montana. And I wouldn't be in this job today if I hadn't been kind of doing what you're doing right now, a research project in high school. I had the opportunity in senior physics to get involved in kind of a research project, and that led me into college to doing undergraduate research. And through a series of events, I was a chemistry professor for 20 years and had a great research program, really a fun research program with high school students, undergraduates, graduates, and so on. But it was that research role that eventually brought me into a leadership role at the university I was at before, and through a series of changes ended up being the president at the University of Montana. But I wouldn't be here if it wasn't for that research project that I had done as a senior in high school. So be careful where you're headed with this. You might end up being a university president or something like that one day, which is a lot of fun. So, well, welcome to the University of Montana. We have such a great environment here, a wonderful learning environment. We do everything we can to get students involved in special opportunities in the classroom and beyond the classroom. So our students, they're studying abroad, they're doing research projects, they're very involved in community service projects, service learning and things like that. So the educational experience at the University of Montana is all about the big experience, not just what you do in the classroom. That's a very important part of it, very important core part of it. But we want to make sure that all of our students have the opportunity to go way beyond the classroom and get involved in the kinds of things that we're doing now, and have the opportunity to showcase those then to their fellow students here at the university and beyond. We always send some students to the national conference on undergraduate research, and there's another event in Washington, D.C. called Posters on the Hill, where students go present research to our congressional delegation and people like that. So the research projects that you're involved in now will open so many doors for you, and we work really hard at the University of Montana to keep those doors open and provide as many opportunities as we possibly can. So I'm glad that you're here today. I wish you the best of luck in your presentations or your posters, and thanks for putting in all the extra time that I know you have this year doing these kinds of projects that ultimately will help people's quality of life and help our environment. So thanks very much for being here, and good luck today.
All right, thank you, President Engstrom. So we have a new initiative here at the University of Montana called the University of Montana Health and Medicine. And I'd like to introduce Dr. Reed Humphrey, who is the Dean of the College of Health Professions and Biomedical Sciences, who's going to tell you all about it. Dean Humphrey.
Normally, I don't really need a microphone, but since the president used one, I guess I will too. Well, I'm going to put mine on. Thanks, Tony, and welcome. As Tony mentioned, I'm the Dean of the College of Health Professions and Biomedical Sciences here, and also the architect at UM Health and Medicine, which I will talk about in a second. But I would like to remind the audience, I wanted to welcome you because of this symposium. So my story, because everyone should have a story, I've always had stories, I've got a story too. Some of mine are true. This is a true one. I grew up in Pittsburgh, Pennsylvania. And I grew up in Pittsburgh, Pennsylvania a while back. And a while back long enough that my parents were steel workers, and we lived hard along the banks of the Monongahela River. And the Monongahela River is a river that flows north from West Virginia. So they brought coal up the river through along the last port, the little town that I lived in near Pittsburgh, or on the river, to be used in the mills. And so as a little boy, my appreciation for a river was this color black. Nothing lived in a Monongahela River. Further up in Ohio, everyone joked about the Cuyahoga River catching fire. The air quality was pretty horrible, actually. But as a little boy, I didn't really appreciate so much of that. My parents were still working. We didn't travel very much, so that was sort of the environment that I grew up in. It wasn't until later, until I was in junior high school, and then finally high school, that my parents moved me away from Pittsburgh, knowing full well that if I stayed there, I'd end up in the mills, because that's what everyone did. You went directly from high school to the mill. The relevant point of the story is that over the course of the next 20 years, the city of Pittsburgh, in cooperation with the University of Pittsburgh, School of Public Health, and other entities, embarked on a 20-year plan to clean the air, clean the water. And that was an effort that was all hands on deck, trust me, because you still had a steel industry that was struggling. You still had incredible sources of pollution all up and down the rivers, from the Allegheny to the north, from the Monongahela to the south, and then the Ohio River, and that just flowed downstream to Cincinnati and down to the Gulf. But they did it. There may be a day, and perhaps some of your teachers have been to Pittsburgh in the last few years, but the water's clean. There's actually fish in the river. I'm not suggesting that we would necessarily eat them, but there's fish in the river, there's boating, there's recreation. The air is remarkably cleaner. But that said, it's always a challenge. And the city of Pittsburgh knows it, Cincinnati knows it, that every effort you make to clean the air is only as good as your persistence in sustaining good air quality. There's always a threat. So we do it. So we've done this remarkable job, and it's really quite an impressive story when you look at what Pittsburgh looked like. You can see photographs of Pittsburgh from the 1930s, and where the street lights are on during the day because it's so dark from the air pollution. Where executives who work downtown in Pittsburgh packed a lunch and another white shirt each day in their briefcase, because they would have to change their shirt at noon in order to be relatively clean in the afternoon, and they worked inside. So it's really, you know, it's a remarkable story, but one that has relevance because the persistence of vision and the persistence to keep the air clean is something that requires vigilance from all of us. I know that we've got kids that, as Royce was checking the constitution of the audience that are even pre-junior high school. And you'll still be working on those same issues. You never can take your finger off the pulse of the environment. When I arrived in Montana, I was like, you know, of course, you know, I'd had the opportunity to be around the country, and then when I moved here, it was like, why wasn't I here 30 years earlier? I don't know, but I'm here now, and you never get me out of here. I'm in this college, which has a number of health professions programs, physical therapy and pharmacy, social work, and public health, which is a growing department or school, I should say, within the college. One of the really remarkable revelations for me was when I arrived, I came here actually as chair of physical therapy like 10 years ago, I guess. And I've been dean for the last couple of years. But one of the things that I really began to appreciate about this university and about this college is its depth and breadth of biomedical research on top of preparing health professionals. You know, we prepare lots of kids to go into the healthcare workforce. And that's part of the University of Montana Health and Medicine Initiative that I'd like you to explore, and I will talk about in just a second, I promise. And I promise also to be done. But appreciating the depth and breadth of what was happening at this university and this college was really impressive. And I see Dr. Humphrey in the back, who's director of the Center for Environmental Health Sciences. That was like an incredible bonus for me as an individual to walk into a college that has such incredible research and such a robust research program, and graduate students working in really cool laboratories in the Skaggs building and across the university in collaboration with other units on campus. This is really a remarkable place for people who are interested in the environment, who are interested in biomedical research, from the undergraduate through the graduate levels. And so to encourage you to explore University of Montana Health and Medicine. This is an initiative that we put together last year. Just really, it's in many respects, think of it as a portal. It's a portal to all of the programs that are offered on this campus, because as you look across this campus, there are robust health programs offered in the College of Education, in the humanities and sciences, in health professions and biomedical science, and there's biological sciences. So they're all over the place. You kind of have to do some real forensics on the net to really find what, and you used to have to look pretty carefully what you look for. Even Missoula College has 8 health professions programs. So what we did was we put it all together, UMHM, umt.edu/UMHM, which you may have already picked up a brochure on it as well. But I would encourage you just to explore the website, just to see the number of laboratories where you can engage, should you come to the University of Montana, where you can engage in undergraduate research, where you can explore health careers. If you don't, many of us don't know what you're going to do. We don't know what we're going to be doing beyond high school graduation or college graduation. But that's an opportunity in that initiative to pull it all together. So, so my urging is, have a look. If you're interested in health, career in health, medicine, and by health, not just health professions, but biomedical research that studies health and impacts health, or public health, you'll find no better array of programs than you'll find on this campus. And UMH will sort of provide you that opportunity. So with that, I think it's probably best that I turn the science over to people who understand it better than I. I had a lovely research career. Well, I'm an applied physiologist by training. I studied heart failure and exercise, and then physical therapy came later. And I hope to see many of you around. Explore the campus, explore the labs here. I know the schedule's busy. Extend my thanks to the panel of expert judges that have taken their time to have a look at your work, and thanks to the teachers for shepherding your students and motivating them and coming to university. So with that, I'll just say thanks. And I've just been avoiding going to a meeting, so the longer I talk, the longer I get to miss that meeting. But I guess I've got to go, so. Thank you.
All right. Thanks, Dean Humphrey. So just a couple of really important announcements. Where the bathroom is, so you pass it just on the way in. It's right outside the doors. I think the men's is on the right, women's is on the left. Posters, if you have a poster that you still need to put up, see Naomi right there. So that's Naomi Delaloy. They're judging them right now. We are also being recorded by MCAT right now. And then Naomi will be taking pictures later on. So when you least expect it, you're probably going to be on film or have your picture taken. So always be smiling while you're here. A couple of other things. There's a couple of booths out there. So one is our admissions table for the University of Montana. If you're interested in coming to the University of Montana, check it out and just get some information about it. And there's folks that can answer any questions that you have about the university. Same thing about UMHM. So there's a table, I think they moved it outside. And maybe during lunch you could check it out and learn more about what Dean Humphreys was talking about with that UMHM initiative. So they're doing some really exciting things here on campus. All right, so here's the rundown for this morning. So it's going to be kind of fast and furious once we get started. We're a little bit behind schedule, but we're going to make it up here shortly. So 9 presentations this morning. We're going to take a short break, and then we're going to announce some poster titles of posters, and for those folks that I announced, you're going to go back and stand by your posters. So we'll have more information on that at 11 o'clock. Then we're going to finish up with the next 9 presentations. We're going to have lunch, we're going to do evaluations, and then we're going to have an award ceremony where we give away prizes to you guys. So who is here today? So I'm going to call out the list of schools. We actually have 8 schools and about 180 students here today, not including parents and our panel of judges, the other staff that are here, and other dignitaries, and actually other teachers from other schools are here to check it out. So I'm going to call out the school, and I would like for you guys to make some noise. So Big Sky High School. Let's do that again. So Big Sky High School. Where's Dave? So moving right along. So Corvallis High School. Very good. All right. Highland High School. Highland High School. All right, well done. Helena Capital. Just a wave. Good. Valley Christian. That was the teacher, by the way. So, Superior High School. Superior High School. And that was the teacher also. Hot Springs High School. I don't know how I feel about that, but we're good. St. Andrew's School out of Helena. All right, very good. So 8 schools, 180 students, so welcome to the University of Montana. So we have 39 posters that are being judged right now. Like I said, at 11 o'clock we're going to call out some names. The top 3 posters will get prizes. So $100 gift card to University of Montana bookstore, second prize is $75, and third prize is $50. So who in here has a poster? All right, very good. So presentations, we have 18 presentations. So they're 5 minutes each. We'll have 2 minutes questions and answers as soon as the 5 minutes are up. I'm going to man the lights back here. So right at 5 minutes, lights come up, and then that means stop, and then you start answering questions. Same thing. First, second, third prizes. We have awards for you guys. So first prize is $150. Second prize is $125. Third prize is $100. So who in here is giving a presentation? All right, very good. So we have a very distinguished panel of judges today. So they will evaluate your presentations and your projects. There is actually a poster judging panel that's judging your posters right now next door. But this is your presentation panelist. So the first one I'll introduce is Ben Schmidt from the Missoula City County Health Department. Yeah, you want to be nice to these guys and ladies. So Dr. Steve Gaskell from Health and Human Performance here at the University of Montana. Dr. Bill Granis from the Division of Biological Sciences here at the University of Montana. Mary French, staff scientist for Center for Environmental Health Sciences. then Ronnie Flannery from the American Lung Association. And then Dr. Earl Adams is in charge of the judge wrangling today. So Earl Adams from chemistry. All right, so it's time to get started. So this is going to be kind of fun. This is always fun for us to watch. So the way this happens is we will randomly select a presentation, and we don't know which ones we're going to select. So once I pull it up, then you guys run down here as fast as you can, and then we'll get settled, and then you'll start your presentation, okay? It kind of keeps everybody on their toes.
Okay, hi guys. My name is Abby Dunn. This is Liam Hull, Penny Jessup, and Justin Katnack, and we're from Corvallis High School. And we tested the effect of cigars versus cigarettes on our air quality and how that affects our health.
So does cigarette or cigar smoke lead to higher health risks? Thank you. The purpose of this experiment was to test whether cigars or cigarettes have a higher PM 2.5 level, and then in return, which one is worse for your bodies when you breathe in that air.
Our hypothesis is if cigarettes and cigars are smoked in the same space, then the PM 2.5 level will be lower with cigarettes because they have a filter while the cigar does not. Also, the technique in smoking of a cigarette is different than that smoking a cigar, which also affects the PM 2.5 level.
So, just some health risks of smoking cigars. There's a high risk of developing various types of cancer, especially in the head, throat, and lungs. There's a higher level of toxins in cigars than there are in cigarettes. It can cause addiction, can cause or worsen symptoms of asthma, and also can cause airway damage that leads to COPD, as well as contributing to gum diseases, teeth rotting, and that kind of stuff. So, and then some of the health risks of cigarettes, which are really similar to cigars. There's a high risk of lung cancer. And lung diseases such as COPD can potentially harm every organ in the human body, leads to addiction, and can also lead to heart disease.
So secondhand smoke is a big one. So that's broken up into two different categories. You have your mainstream smoke, which is the smoke that's exhaled by the smoker, and then you have your side stream smoke, and that's from the lit end of a cigarette, a cigar, pipe, or like a hookah if you're smoking out of a hookah. And so that is much more toxic, and so it also has smaller particles that make their way into your lungs, in the cells in your body a lot easier.
So we gathered some similarities and differences of cigars and cigarettes. The time to smoke, it takes longer to smoke a cigar than a cigarette. The nicotine content is much, much higher in a cigar than a cigarette. There's a filter on cigarettes, but there's no filter on a cigar. Secondhand smoke is produced by both of them, and you inhale a cigarette, but you don't inhale a cigar.
So the procedure we did for this experiment is we measured the air quality and humidity in the controlled environment, which you can see by the pictures. And then we gave an adult a cigar to smoke, and during which we recorded the air quality inside the environment. And then once the cigar was smoked to completion, we gave him a cigarette, and we repeated the same procedure. These graphs show all of our results from the trials. On the left you can see the cigarettes, and on the right the cigars. The straight bar in the middle is the EPA 24-hour standard, and as you can see on both graphs, you can see that cigars and cigarettes are much higher. And the little arrow shows when we started smoking, so you can really see how the air quality really took a hit. And these are the comparisons between the trials. Each one is a comparison between cigarettes and cigars for each trial. And as you can see, in every single one, cigars don't fail to be much higher than cigarettes.
So for a conclusion, based on the results, our hypothesis was correct, and cigars produced a much higher PM 2.5 level than cigarettes. And so this conclusion shows that cigar smoke may result in a higher health risk involving particulate matter in secondhand smoke than that of a cigarette.
Some improvements and changes we could have made. Same amount of time for every trial. Use different brands of cigars and cigarettes to get more of a variety. tested it in a more controlled environment, like places with restricted airflow, and tested on various number of smokers. Any questions?
Yes, if you had given them the same amount of time smoking a cigarette as a cigar, so maybe multiple cigarettes, what do you think your data would have looked like?
That actually is what we did. Like, we didn't exactly explain it in the presentation, but each one we smoked multiple, we smoked multiple cigars and multiple cigarettes for each set of that data.
So it should be like the same. So that it should be constant there. Okay. Any other questions? Anybody? Music Matters with a focus on particulate matter. My name is Kaylee Rosenbaum.
I'm Tatiana Millett-Yoke.
I'm Chelsea Shire.
And we are all from Big Sky High School, and our teachers are Mr. Jones and Mr. Faraday.
So our research question was, where is particulate matter during a band concert, in the audience, or on stage? So some of our things from our background is particulate matter 2.5 is the smallest particulate matter, and fine particles are between 2.5 and 10. And right now you can see that they're compared to a human hair and a grain of sand. And the purpose of our project is that particulate matter can get into our bodies and in our lungs and cause effects as aggravated asthma, decrease in lung function.
So our hypothesis is if particulate matter is measured on stage during a band concert, then it will be greater than the particulate matter measured in the audience because there's more air movement on stage due to the greater output of air through instruments.
For our procedure, our first concert was held at Big Sky High School in the cafeteria auditorium, and we set a dilose particulate counter in the middle of the audience, and then we placed another dilose particulate matter on stage behind a row of musicians. We turned the counters on at the start of the concert and we let them run into the end. And the second concert was held at Great Falls in the Great Falls High School auditorium. The concert was much larger and had a larger audience, multiple bands playing, and we placed the counter in the audience in the center of it and on stage again behind a row of musicians.
So these are our results, and these first two graphs are the control we took, and we took these about an hour before the first concert at Big Sky. Based on the graphs, we can see that they're very similar for the stage and audience, the audience being on top and stage on the bottom. There are a few spikes that occurred. I was observing the dilose particulate matter, make sure no one messed with it, and a few people moved through the area. And the few spikes around 17 minutes for the audience, and then about 45 minutes the band director was actually on stage adjusting a few things before the concert. These are the results from the first concert taken at Big Sky. If you look in the top right-hand corner, you can see the averages of the small particulate matter and large particulate matter. These results were pretty inconclusive. They were very similar, and there wasn't much difference between the audience and stage. As you can see, the small was not much smaller than the stage compared to their averages. This is concert 2, and concert 2 gave us much more conclusions about our experiment. You'll notice on the audience that the time was run for about 30 minutes, but in actuality it was actually an hour long. But the rest of the results hover between 0 and 7, and it was just a flat line, so we felt that the graph didn't really need it to show. We included those numbers in the averages. You can see the averages are much bigger difference. There's 474 for small for stage, and 178 for the audience. And we found these graphs support our hypothesis quite a bit, but there is a big spike in the audience. I'll have to explain. The bands had to shift every 20 minutes or so that they could go on stage, so there was a lot of movement in the room, which moved the particulate matter around. And then on stage, there's a few spikes every few minutes or so. That was from the band shifting around to change music in between songs.
So from the analyzed data, we reached the conclusion that particulate matter is produced more on stage than in the audience at a band concert, which therefore supports our hypothesis.
However, with our conclusion, we do realize there needs to be further study because we only were able to get one conclusive set of data, so we need to keep running more trials.
We chose to use the city of Hong Kong for the real-life application because Hong Kong faces one of the biggest air quality problems on the planet, which is pollution. According to the Hong Kong Air Quality Index last week, the city had a moderate level of 66 in air quality. Not only is the air quality affecting China's health, but it could affect their musical culture. Knowing that more particulate matter is produced on stage than in the audience, better ventilation could be developed in performance halls.
And these are our references. Is there any questions? Yes.
Could you go back to the graph with concert one? So it's both of them start a lot higher and end a lot lower. Why do you think that is?
I think that's because when I noticed when I was kind of messing with the Dilos log things, they sort of spike at first when they settle into where they're at. And I think that's because it's trying to absorb its surroundings. I don't really know how the technology works specifically, but I assume that's just because the particulate matter is settling down and it gets used to where it's sitting.
Can you go to your second graph? And on this one, if you look early up to about 22 minutes, it looks like the numbers of the small particulate matters are about 400 in both graphs. And yet you said that it's 178 is an average on your small. How do you get 178 when it's pretty constant 400 in the top graph?
Because, like I said, we had this one's cut to 30 minutes, the audience, and so there was about 30 minutes of 0 readings or 1 or 2 readings, and that brought the average down quite a bit. There may have been mathematical error, which might explain that, but for the most part, we're fairly certain it was those low readings that brought it down. Any other questions?
We really encourage questions from the audience too. So I found this extra bag of goldfish. Needs a home, so first person to ask a question gets a bag of goldfish. Guy in the back. I don't know if I can make it up there. Yeah, you.
Was what, all on the same day?
Was the concert on a different day? Is that your question?
So yeah, there were 2 different concerts held at 2 different times during the year. One was in about November, and the other one was held in February, or end of January, around there. Yes.
Do you think that the different months or different time of year have affected your quality?
Yes, we forgot to mention this, that the heat was up a little more in the Great Falls High Auditorium, which we think also explains the much elevated levels of PM. Also, the Big Sky Auditorium is not really an auditorium. It's a really big open area with a lot of airflow going through there. So that might have explained those results. Anybody?
Right. Great job, guys.
Hello, my name is Larissa Sweet, and this is Anna DeCan. We are representing Valley Christian School and our chemistry teacher, Mrs. Gladwell. Our experiment was based on air particles and the effect cats have upon them. All right, so to start, we have health risks. Some of the health risks that many people are unaware of are caused by the particulates given off by the animals that live with us. We could have tested dogs and further animals, but cats have less variables that are related to them. So some of the health risks include pet dander, mites and fleas, poor hygiene, and the added activity of animals, which causes an influx of dust. So this can cause problems in allergens and this can cause problems for people who have allergies and asthma. Because due to their microscopic size and rough and jagged shape, they are easily spread throughout the home on carpets and clothing and everything. Our hypothesis was that the air particle levels in a room will increase proportionally with the number of cats that are placed in this room. Our purpose was to show that the addition of animals to a household will cause increased levels of air particles.
All right, so we tested, sorry, the pictures aren't supposed to be like that. We tested both one cat and two cats, and the procedures were very similar for the same. So first we started with a room with little airflow. We had a dog carrier that we covered with a blanket, and we tested initially for 20 minutes by putting the Dylos tester between the blanket and outside of the kennel. Then we put one cat and then two cats later in the kennel for 2 hours. And then once we had the results, we took them out and measured for another 20 minutes. And so these are some pictures of the single cat. And then those are the double cats. All right, so for our results,
As you can see, there's a greater influx of both large and small particles found in the air after the addition of the cats.
all right, so for this experiment, we ran into a number of variables which caused problems and obstacles in our experiment. Some of them were the breed of the cat and the hair length, and the age of the cats, differing locations and cat activity, and also the size and type of the kennel and blanket. So for our conclusion, we got that based upon the data collected, we can conclude that the addition of animals to a household will greatly increase the levels of pet dander found in the air. From this, we can extrapolate that possibly, with proper cleanliness of the animals as well as the household, any danger to humans is lessened. Are there any questions?
Can you go back to your data slide, your graph? And why do you think that you have two cats, but two cats are much higher than, they're more than twice as much as one cat? Why do you think that is?
I believe that a lot of it was caused by the age of the cats and the fact of playing and kicking up dust, and just that, as opposed to my cat, which was the single cat who would just sleep the entire experiment away.
So they were different cats when you had two cats together than one cat. Okay.
It's weird, I found this back there too. All right.
So, can you tell me how old your cats are?
My cat?
All of the cats, yes. She was saying that hers is older, so how old is your cat?
My cat is about 3 years old. How old are yours?
Mine are 9 months to a year old.
So hers are relatively.
There's another question in the back.
Why do you think the age
Well, it just allows them, they'll be playing more and there's more energy in it, so they'll be moving more, and which will cause rubbing up against the sides of the walls and kicking up dust from that's initially in the box and everything.
What kinds of cats are they?
Mine's an orange tabby.
We adopted both of ours, so we don't know.
Do you think the kind would affect your experiment?
I do, and we had that under variables because if they have long hair, it could add to the amount of particulates that are caught in there and given off.
Okay, now, I don't want to argue against any of your things that you stated earlier, but I would like to mention that it doesn't always depend on the age, because personally, my cat, about mid-age, does nothing.
Well, I agree with that, yeah. I've had cats that are both spectrums.
And there, one in the back.
We put it between the kennel, which had a grate in the front, and the blanket, so.
How do you think the results would have changed if it would have been inside just a normal room rather than inside?
I think the air particles would have spread more rapidly throughout the room and it wouldn't have been as accurate.
Did you have like a control, like of just like how the camera was with the blanket?
Yeah, initially we tested for 20 minutes before we put the cats in, and then on our data, we took the differences from the two.
There we go, one more right there. We'll move on.
How did you get your averages for the large particle one? Can you go back to the how did you find your averages?
We added up the 3 trials and then divided them.
I was just wondering because the 2 cats large particle average is higher than all the other data.
Yeah. Yeah.
Great.
Okay.
Great job, guys.
Thank you.
Hi, my name is Brandon Moore. This is Avery Walden, and this is Oz Hershey. We're from Corvallis. We're here to present our study on the effects of 4th of July fireworks on air quality in Hamilton versus Missoula. Our tested question is, which city will have the worst air quality on 4th of July, Hamilton or Missoula? Our hypothesis is that Missoula will have the worst air quality because larger population means more fireworks. Some possible factors that affect the outcome are temperatures on the 4th, the geography of each location, and any firework bans due to fire risk.
All right, so we found a website that got the the mean, max, and minimum temperatures for. First off, we found the data for 3 different years: 2012, 2013, 2014, and so as you can see, in 2012, the temperatures were a lot lower than they were in the other 2 years. So
Disregard the formatting issues that happened when it was transferred onto this computer. It's in order, chronological order, 2012, 2013, 2014. All right, so that's in Hamilton.
And then, as you can see, it's very similar in Missoula as to Hamilton.
Let's go. All right, so here is the graph of Hamilton. As you can see, this point here gets real high. That's about at 11 midnight. You see the fireworks start going off there. They get up really high, and that was in 2014, which is a recent year. And 2013 was really low, a lot lower than any of them. It was even below the EPA standard for health. So, interesting data. Let's compare it to Missoula. All right, Missoula, with more population, had a much higher peak at 235 particles per but 2013 also had a very low peak, just like in Hamilton, and that is because, we'll talk about that in a little bit. 2014 was a little higher, but yeah, 2012 was very high for Missoula. But let's go to the next slide. So then we averaged out all 3 years for Hamilton, Missoula, and you can see Missoula goes up to a higher point, but it drops off a lot quicker. And then Hamilton, it is a slower curve, and yeah. Alrighty. So our outcome, Missoula had a much higher peak level, and that occurred around 11 to 12 p.m. Hamilton's level dropped off a lot slower, and there wasn't really a relation between the temperature and the air quality, as 2013 was higher temperature than 2012, but it was still the lowest air quality for all 3 years. And yeah, 2013 had the lowest. Now, reasons behind this. In 2013, there's a fireworks ban in Missoula and Hamilton, so they were not letting people fly off any fireworks. So there was, as you can see from the graphs, there was a lot lower particle levels. And Missoula has a much higher population, so on those years, there was more fireworks going off. So now let's look at the geography of both Hamilton and Montana, or Hamilton and Missoula, and see how that affected the results.
So this is like a picture of the geography of Hamilton, and as you can see, it's kind of like a narrow valley with mountains on both sides, and that can easily trap in a lot of particulate matter. And then next slide. In Missoula, a little wider valley, still mountains on both sides, but in Hellgate Canyon, a lot of wind can come through that and take out a lot of particulate matter.
So in conclusion, Missoula had a lot higher PM 2.5 levels because of population, and that affected more fireworks, but they dropped a lot quicker because of wind currents moving through a lot faster. And a firework ban will greatly improve the air quality, even though it might not be as fun 4th of July. So, any questions? Yeah.
Did you collect these data, or were they?
No, we used the svc.mt.gov website to look at past years of data.
Okay, thank you.
Found another one. This soft and chewy bar. All right, guys, back.
No, because on the website there wasn't complete data for 2015's 4th of July, so we just used 2014, 2013, 2012. Yeah, you. No, that wasn't really part of our tests. It was more just about the whole town as a whole, but I bet there are more fireworks, explosions are creating a lot of particulate matter.
So was the ban a public ban, or was there still fireworks
Well,
by the city?
yeah, it still went up a little bit because they'll have fireworks shows and stuff that are more controlled, but they banned public fireworks and stuff like that. Okay. Thank you.
Hi, my name is Mackenzie Skellinger, and this is Jade Smith and Heather Rossa, and we're from Hot Springs High School, and our project is air quality of our school. The danger of small particles less than 10 micrometers in diameter are the most dangerous. They can get deep into your lungs and can even enter your bloodstream. They can cause health complications such as premature death in people with heart disease and lung disease, non-fatal heart attacks, irregular heartbeat, aggravated asthma, decreased lung function, and increased respiratory symptoms. Or methods. The Dialos machine was placed in 3 locations around the school to gather data. The machine was placed out of the way so as to minimize interference. It was not placed near any vents or windows. The 3 places were in the science room, the culinary classroom, and the elementary teacher's lounge.
I guess. Hey. Sorry about the text. It kind of didn't transfer well. Okay. So the first site we placed the Dialos machine was in our science classroom. We placed it up in the ceiling, which wasn't too bad. The first initial spike, right
right there is just from us moving around and having to move ceiling tiles and stuff. It did eventually come down a little bit more. The building's fairly old, so we were warned there was asbestos up there, so it's mostly what it's tracking. The second one was in the culinary classroom. Unfortunately, there wasn't anybody cooking, so no fire smoke to measure. The first big gap there is because we had to walk outside to place it in the culinary classroom, so that's mostly just outside that it's picking up. And Site 3, we placed it in the elementary teacher's lounge. Once again, we had to walk outside, so there's a bit of a spike. The teacher's lounge in the elementary is just 4 rooms placed together, and there's a lot of foot traffic in there, so the particle count's quite a bit higher. For the comparison, they're not overall that much different. There's only, I think, 2 or 3 spots, like right here and over here, where they dip below the 135 micrograms per cubic meter, which is the EPA regulated for hazardous air quality.
Our conclusion, according to the EPA's air quality standard of 135 micrograms per cubic meter or more, the Hot Springs High School's air quality is unhealthy. 3 different sites, each varied in age, were tested. In each site, the air quality is hazardous while school is in session. When school isn't in session, the air quality was poor. Further studies would have to be done to solidify our results.
Any questions?
What do you wish to do with this information?
Just to inform our school and so that we can realize that it is a problem and that then we maybe as a collaborative effort we could work to fix it. Any other questions?
Why is the air quality so much higher or poorer during school than when school isn't in session?
Because there's a lot more people, a lot more foot traffic and stuff. Yes?
How long did you test, run the monitor in room 4?
We left in there for I think about 10 hours, 2 of which were after schools. Yes?
Do you have access to information, similar information for other schools in the state?
We did not. Anyone else? Good job.
So, I am Camus Van Dale. I come from St. Andrew's School, and my teacher is Mrs. Buffington. My question is, how does kitty litter affect the air quality, or PM 2.5, in homes while the litter box is being cleaned? My purpose is to find out how it can affect people, because some people have bad asthma problems, and some things used in kitty litter can cause some diseases in the lungs. My hypothesis is that while the garage door is open, cleaning the kitty litter will increase the PM 2.5 levels in both the home and the garage. The air is being pushed around by the doors if they are opened or closed, and each time they are, it pushes air and the PM 2.5 around the whole area. And when the air is trapped, it keeps the PM 2.5 in the garage and the house, it can be bad for your health. My procedure of how I did it is we use the Dylos sampling protocol. First thing we did was sample the ambient air in the room we cleaned it. And each time we cleaned it, I used the same method for cleaning. I had many independent variables such as the garage, door, the house door, and both at the same time. The dependent variable is PM 2.5. This is my first graph with both doors closed. As you can see, it starts out kind of jagged and then like with a high spike because we had just turned it on and closed the door. But then this is when we cleaned it right there. And then as you see, it goes down and then keeps going at a steady pace. The next one was with the house door open. And as you can see, that's when it was just getting the ambient air. Then when we cleaned it, it goes straight up, then straight back down. The first on this one was with the garage door open. And we just got the ambient air for a while, and then we cleaned it. And as you can see, this was one of our high spikes there. Now, these are with both doors open, but not at the same time. So we had just turned it on, and then we cleaned it with the garage door open, waited a little bit, and then it settled down. And then we cleaned it with the house door open. The results in all 4 tests, there was that high spike, and the largest amount of PM 2.5 is 200 micrograms per cubic meter, and that was when the litter was cleaned in the garage with the house door open. The conclusion is when the garage door is open, it will improve air because it is a larger door and it can push fresh air in and push the PM 2.5 out. The litter takes a longer amount of time to settle because of the mixing of the air. And even though the PM 2.5 is at a high level, it is not at a dangerous level. It is right below the unhealthy level. And that's it. Any questions? No?
Did you ever test to see how the air quality was inside of the house?
No, we didn't.
One thing, about how big was the second garage?
For an estimate, I would have to say maybe area-wise 30 by 20 feet, maybe 30 by 25.
Now, do you think that a larger or smaller garage would have, changed your data?
It probably would have made the particles larger because it's in a smaller area. It would have gotten mixed more because with an open garage, you have like a whole bunch of space for air to go through.
So do your results mean that you still have clean kitty litter?
Yeah. We cleaned it in the garage now just because it's safer and not as bad on people.
I'm Grant Martin, and this is Ryan Milliman, and today we're doing our presentation on the effects of burning propane and butane.
Try to do it. Oh, there we go. All right. So our hypothesis that we believe that burning butane in a closed space, such as a garage or a shop, will produce more harmful PM 2.5 levels compared to propane due to the fact that the butane molecule is larger.
All right, so our factual points. The butane molecule is larger than the propane molecule. As you can see, butane is C4H10 and propane is C3H8. Propane burns hotter and performs a more complete combustion, and it's more widely used and easier to be obtained.
Here are our materials. We had a propane torch and a butane torch, and we found them both with variable gas releases. We set them both to about 2.5 on the dial and a Dialos air quality monitor. Our procedure is we set up the Dialos about a foot away from the open flame of either propane or butane, and let sit for the next 2 minutes. The garage is given 10 minutes to clear in between the tests to ensure accuracy, or to ensure accuracy, we made sure the burner flames were set to the same amount of gas released. So here are our graphs. The orange one is butane, and let's see, about right there is where we. Oh, sorry about that. About right here is where we lit the flames, and this immediately jumped up for both of them. But butane, it goes up and it's kind of saying that it spikes again, it just keeps like going up. While propane is just kind of a flat line with a couple of dips and bumps. And then the gray line down there is the EPA 24-hour standard. As our hypothesis predicted, burning butane in a closed area is much worse than burning propane.
So for improvements, we could check that the 2.5 burn rate, like on the dial for the torches, gives you like the exact same ratio of gas leaving the tank, and we could have a longer time for the particles to cool down and a longer test session. So questions? In the back? Yeah, the torches, they're about the same size. Yeah.
Was this just one trial, or did you do multiple trials and this was an average?
We did one trial, but we gave it a lot of time in between to clear.
How did you decide on the 10-minute time period in between?
Well, we just thought that'd be an adequate amount of time for the dust and stuff in the shop to settle down. No, it's all right. Thank you.
Okay, hi guys. I'm Emily Berry, and this is Nicole Ames, and we're from Capitol High School. Our main anchor to this project was, does the burning of gasoline or diesel raise particulate matter levels more?
What kind of started this question was the knowledge that we use transportation every day, like to go anywhere. And so we were kind of researched it, and we found that transportation is one of the biggest contributors to air pollution.
So that led up to our research question, which was, how does the burning of gasoline and diesel compare in emitting PM 2.5 in a slightly enclosed area?
So we both kind of had different hypotheses about what was going to happen. My idea was that gasoline was going to emit more particulate matter, mostly because I know that diesel takes an easier process to refine, so it's kind of like a more pure substance.
And I predicted that diesel would emit more particulate matter than gasoline because, in my opinion, like diesel exhaust tends to blow more smoke, and the smell of it is stronger than gas to me.
So to answer this question, we used the Dialos DC 1700. We plugged it in about like a foot or two away from where the exhaust pipe was of the diesel truck first, and then we plugged it in a little bit, the gasoline car, pardon me, was first, and then we did the diesel truck, and we left it running for 15 minutes in a garage. So with the car, you can see that there are a few peaks, and at this point I was kind of just sitting there, and I noticed that the wind was blowing, so my guess is that right around these times there was some gusts. And then when I did the diesel truck, there was none.
This graph shows our averages. So On our x-axis, you can see that it's the number of particles divided by 100, and on the y-axis is gasoline versus diesel. So you can see that gasoline has like a huge, like way more than the diesel because, okay, so it shows that the diesel is at like 750 and the gas is at like 7,608, a little above that. So that proves that it's like 10 times more. Okay.
So the data supports my hypothesis that the gasoline emits more particulate matter than the burning of diesel. Question or variables that we have are maybe different makes or models of the cars or trucks, different years, and if we try it in different areas and how this will affect, and kind of how this will be included with around the world. And
okay, so based on our information, we can't tell you to drive diesel over gas because these are only, we only tested 2 of the millions of vehicles out there. And also, there's other things to consider, such as like the chemicals that the dilose doesn't pick up, and yeah.
so, any questions?
So you said you tested in between a pretty large truck and a car. So what do you think the differences from this test to a test if you use the same kind of fuel efficiency and size motors between gas and diesel? Like instead of using a gasoline car, if you used a gasoline truck in comparison with the diesel truck?
Well, I guess it would really depend on like the size of the engine and
like the type of.
Yes. Like we were mostly just looking at the differences between the burning of diesel and the burning of gas. That was our main point.
So how many trials did you guys actually do?
We only did 1 trial, and that was another downfall. We did not have enough time. Other people needed to use the dilose, so we only got to do 1 trial. We would have liked to do more, but we did not.
How did you make your averages from 1 trial?
It was over the 15 minutes per every minute. We made like an average.
Did you guys burn through the same amount of fuel through both vehicles?
Well, it was just sitting in a garage, so.
Did you guys burn like gallons of diesel and a gallon of gasoline? Was it like the same amount? Did you guys do different?
It was just over the time of 15 minutes. We didn't think to do it over gallons.
Do you guys like see the cars or do you just like kind of round them up or just run them up there?
We just let them run.
All right, good job, guys.
My name is Brianna Canning. This is Janu Vang and Quinn Deal, and we're from Big Sky High School, and we tested different radon levels in Missoula soil.
All right, so our question was, does soil type have an effect on radon levels? And the purpose of this was to investigate the certain soil types in Missoula and see if any of them have a larger amount of radon. And then the results of the experiment could inform homeowners if they had potential radon levels that were too high.
Okay, so our hypothesis was if the soil types differ between locations, then radon levels will also differ because different soils have different amount of uranium and are composed of different materials. And just if you didn't know, radon gas comes from the natural breakdown of uranium in the soil.
Okay, so our procedure started with determining our locations around Missoula, and we chose 5 different soil locations using Web Soil Survey on the USDA website. And then the second part of our procedure was filling 5 5-gallon buckets with 2 gallons of the soil from each location. And then we drilled a hole in the side of each bucket, put the wire through to the radon, and left the detectors in the soil. Then we closed the lid and duct taped the rest of
the holes so nothing would get out during the process. And then we turned on the power strip and started our data collection. Finally, we read the radon levels after 48 hours and then continued every 48 hours for 2 weeks. So that left us with 7 readings after 2 weeks of data collection. And then we repeated this procedure for fall and spring.
And this is just a list of the locations that we collected soil from. So we collected it from Brianna's house, Prospect area, Greeno Park, Sacagawea Park, and Big Sky High School. And so this is just a graph of all of our data. So there's the fall and here's the spring. In the fall, Brianna's house was the highest radon out of all of the locations that we selected, and Prospect was one of the lowest along with Greeno. But in the spring, our data totally flipped, and now Prospect and Greeno became the highest while Brianna's house became the lowest. And this is just the average radons for the 2 different seasons, and as you can see, the spring is a lot higher than the fall.
Okay, so our conclusion is based on the results of the experiment, there is a difference between radon levels in the soil, and so our hypothesis is supported. So our results, this is just a table of, on the first column, we have the locations and the type of soil found at each location, and then the appearance of the soils when we collected them, and then the fall average radon level and the spring average radon level for all 7 readings for the 2 weeks. And this just shows again, like my house, it goes from really high to really low, and the totals like actually completely flip-flop. It's really odd, and we don't know why that happens. So for further understanding, we obviously had an interesting question, and we were wondering why the radon measurements from the fall and the spring invert, and why the spring radon levels are higher on average than the fall radon levels. And to try to answer these questions, we investigated the average daily temperature for each day of the collection period and the minimum sea level pressure recorded for each day. And we do have that data if we have more time to talk about that. I'll just do it anyways. Okay, so these are the average fall temperatures and the spring temperatures. Down below you can see that the spring temperature was higher overall. So this explains why the spring radon levels are higher, because if there's a higher temperature in the air, more gas particles are going to move around more. And so that explains why they're higher overall, but it does not explain the inversion between the fall and the spring. And then the sea level pressure is higher in the spring as well, which also explains why the spring levels are higher, but it also does not explain the inversion. Any questions? Yeah.
I was wondering, the point from your house?
Yes.
Did it come from a crawl space or outside?
It was outside, but the fence.
As was the rest of the
Yeah, they were all outside. Yes.
Can you explain the thing you did with the buckets?
Re-explain it?
Yeah.
Okay, so we, like, digging the hole, or like?
Just how you, with the radon stuff, the radon detector.
Okay, so we drilled holes in the side of the buckets, which allows the cord to run through the bucket without having to like go through the top. And then we plugged the hole with duct tape so any of the gas wouldn't escape. And then we kept the radon detector inside of the bucket and closed the lid, so the source of the radon was contained in the area the whole time. And we only opened the lids for a few seconds to check the reading each time. Does that answer your question?
Yeah. How can you tell that it was the radon particles that were being picked up by the dialos instead of?
We were not using a dilose detector, we were using a radon detector.
Cool beans.
Yeah.
So how would you apply this like every day?
Well, since our conclusion is kind of odd with the inversion between the fall and the spring, we're not really sure what our results mean. And so we would, of course, need to investigate more soil types, maybe different locations, and also repeat the procedure for the same locations to see if the inversion continues to happen.
So follow up.
Okay.
So is radon like bad for you or is it dangerous?
Yes. So obviously, if
So if I were to place the radon detector in my basement and I had a radon level of over 4, I believe it is, for a certain amount of time, that is very harmful for your health. It's a really, it increases your chance of developing lung cancer and other diseases. And so obviously you do not want to have radon in your basement, so it's important to know if you're at risk or not. Yeah.
So is radon considered particulate matter?
I do not, well, it's a gas, so not necessarily, but it's obviously in the air. Yes. Go ahead.
Is there anything you can do to decrease the amount of radon around?
Yeah, so at my house I have a system actually under the foundation because we did find radon in our basement. And so there are filtration systems that you can install under your foundation that will filter the radon out so you don't have to worry about it. So if you're concerned, get your house tested.
So we got one more right here and then we're going to take a break.
Did you notice any correlation between soil types and radon content?
Not necessarily, because all of the soil types were fairly different. That's why we chose the locations we did. And so we would have to do more testing with that to figure it out.
All right, very good. Okay, so we're going to get started again. So we have 9 more presentations to go, and we have Raylan Davis from Highland High School in Idaho that's going to kick us off for the second half.
Can I set this down?
Yeah, whatever you need.
Okay. So my name is Raylan Davis. I'm from Highland High School, and my research was on the bioremediation of air pollution due to wildfires. So in the 2015 fire season, Idaho had over 300 fires, and that made this the worst season since 1911, and they were all actively smoldering and releasing toxins. In August 2015, we had a moderate air quality ban, and then in September, we reached an emergency air quality ban, which restricted our outdoor use, and then both of these negatively impact existing health conditions. These are some of the common composition of wildfire smoke, and these are some of the factors that will affect it. We were exposed to this smoke in every way. It was unescapable. In our houses, it came in through ventilation systems and windows, and outdoors, we couldn't drive for hours to avoid it. And it was also during harvest, which is a very active outdoor employment season. I had also had to leave work early and have asthma, and so I was looking for a solution to this problem, and I had found that NASA had done research and found that houseplants do photosynthesis clean air. And they also tested for these 3 pollutants, which are also found in wildfire smoke. So my question was, can potted houseplants be used to reduce particulate levels in the air due to smoldering wildfire materials? And then which houseplant would be the most efficient in reducing particulate levels? This is my hypothesis. It basically states that houseplants will be efficient in cleaning the air with wildfire smoke. These are my protocols. I basically decided to use a fume hood with a smudge to try to recreate the situation, and I used a dialyose to read the particulate levels. This is my layout of my fume hood. It was just out of convenience because I needed the outlets on these sides. I also tested 5 different houseplants. These are the first 3. These were just the ones I had available to me and that are commonly found in households. I encountered several problems during my research. The first was getting the smolder, because how to recreate the exact smoke like we had it before. And then the protocol took me about a month to figure out because I did not know how to control the variables. And then the time length, and I had several inconsistencies even with testing for so long. This is my data. I've tested for small and large particles. I have the peak, the return, and the time, and then the recovery was the peak minus the return divided by the time, and I tested each plant 3 times and have the average recovery rate. This is my plant 1 data, plant 2 data, plant 3 data, plant 4 data, and my plant 5 data. This is my results. So again, my recovery rate was my peak value minus my start value divided by the time it took to go from peak to start. And these are my averages for my small and large particulate matter recovery rates. I also have an ANOVA, which would not upload correctly into my PowerPoint. But for the small particulate levels, at a p-value of 0.0004, and my error bars clearly show that there is a statistically significant difference. And for my large particulates, at a p-value of 0.0077, which again shows that there's a statistically significant difference. NASA had also done research to prove that leaf surface area did not affect how the plants clean the air, and for this I also estimated my leaf surface area just to rule this out. So in conclusion, my question was answered and plants can reduce particulates, and it supported my hypothesis. Plant 2 was the most efficient, and plant 4 was the second most efficient, and my other houseplants were better as decoration than air cleaners. The leaf surface didn't matter, and that's just a fun fact about how many houseplants it would take to clean an average home. These are my implications for future research. These are my sources. These are my acknowledgements. And are there any questions?
Can you go back to your, sorry, a couple slides back, your implications or what? Yeah, just have a second forward back. Okay, and other questions can be asked. I just want to start that slide.
Yeah.
Did you successfully recreate the particulate matter that was in the air?
I couldn't exactly recreate it. I tried my best, but due to the fact that it was no longer the fire season and they didn't have exact readings for how bad it got during the fire season, I just tried to recreate it the best I could.
Were you able to recreate the amount of particulates before you started to put the plant in the chamber?
Yeah, so I set it on a burner and I let it go for 10 minutes and then I put my plant in, so it was already just in the smoke after. So I got a baseline reading and then put the plant in with the recreated particulate levels.
Were the smoke levels and the particulate levels the same at the start of each trial?
No, they each had different peaks due to the way the materials burned. I used the same weight and same materials each time, but they burned at different rates.
Can you go back to how many plants it would take in the previous slide? I'm just, okay.
It's not exactly practical, but if you strategically place them, you could probably improve air quality throughout the home.
If you control for light levels within the hood plant review?
So basically, the plant was only in there for a space of 4 hours, and then it was taken out. So I just made sure that the light was on each time, and the same light, so it was by windows, and it was just the same light each time.
From what I know about spider plants, is that they're grown in water most of the time. Is that true with yours?
No, this was not grown in water.
So, what mechanism do you think was causing the spider to be more efficient than the others?
I'm not exactly sure how it cleaned better, but I also think that the other plants were letting out other particulates into the air, and the dilose was also picking those up. And so I don't know if they would have been the same efficiency if the dilose could distinguish which particulates it was cleaning. Yeah.
When you opened the hood, how much smoke would you say escaped as you were putting the plant in and taking it out? Do you think that affected the results?
Yeah, there wasn't exactly, you couldn't tell when I would open or shut it. The line stayed consistent. I just tried to do it as quickly as possible.
Great job.
Okay, my name is Braxton Roth, and I'm a junior at Corvallis, and this is Hannah Brown. Our test is called Effects of Vacuuming in a Domestic Environment. Our question is, how much worse will vacuuming make the PM 2.5 levels in our homes? So when I would vacuum at my house, I would do it once, and I would kind of do bad, so my mom would make me redo it, and I thought the air would get worse. So I thought it would be good if we could test each vacuum in each other's homes. And when I did my research, I went to CleanLink, and they said in their article title that vacuuming can improve indoor air quality. So we thought
maybe it depends on which vacuum you have. And both of ours are certified by the Carpet and Rug Institute for healthy cleaning.
All right, our procedure was to place the pump in the living room about in the middle, and then we would start the pump, and then we would vacuum each area, and it would take us, it took me about 2 minutes to do my entire living room. I don't know how long it took him, but, and then we would wait 10 minutes, and we redid that 5 times, waiting 10 minutes in between, and at the end of the test, we recorded the humidity, temperature, and overall time of the test. These are our homes. This is the vacuum that Braxton used on the top, and then my vacuum down there.
What kind of vacuums are there?
My vacuum on the bottom is a Shark Navigator, and it's a pretty brand new vacuum. I don't know what kind yours is.
Mine is a Kirby, but we looked on CleanLink, and it says that for thorough vacuuming with HEPA filtration, which is on Hannah's Shark, it can capture particles down to 0.3 microns in diameter. So that includes most of your allergens and dust and pet dander. And we both have pets, and Carpet is really good for trapping that kind of stuff. This is our graph. So the top is Hannah and mine is the bottom. Both of our PM 2.5 levels weren't very high, so at the beginning of Hannah's graph, it started higher and ended lower, and mine increased and then calmed down throughout. My test was a little over an hour, and hers was, just right around there too. So they're pretty consistent test times, but that could also affect our graph if we had different areas to vacuum, because it would take us more or less time. So Shark has their website of the information about her vacuum, and they have patented seal technology that traps most of the dust and allergens, where Kirby just had some information about them saying they have a HEPA filtration, but it didn't really help much. So basically by our chart, we kind of just decided that her vacuum is better because it has that better filtration system. And if you want to clean your house, you should have a better vacuum, maybe. So what we could have done better to do our test, we could have taken both vacuums and done it in each home, and then ran more tests instead of having intervals between the tests. Actually do specific tests if we had the pump for more days than just each of us taking it home once. And then we could have done it on the same day too, because weather can affect like your house and stuff. So yeah.
Questions?
Any questions?
Are golden carpets the same kind of flesh?
Mine's not very plushy.
They're average household carpets.
Yeah.
Did you tell your mother that continuing vacuuming actually makes it worse?
Yeah, so with my vacuum, it kind of made your floor cleaner, but your air worse. But
Mine made my floor cleaner, and it made the air better because it went down. Yeah?
Does your Shark have ability to clean the filter and still how clean it is?
yeah, we could have looked at our vacuums and checked the storage compartments to see how full they were of, your material and stuff.
Mine wasn't actually that clean when I vacuumed it. It was actually pretty full, but it still
Yeah, I'm sure mine
did the
wasn't
job because of the seal technology. And
Now, if I'm not mistaken though, weren't your particulates higher than his?
they were, because the pollution in my house, I think when he did his, it was right after a rainy day. And so mine,
Yeah, we had the pumps on different days, so
yeah.
we couldn't really, that's what we would have changed if we could have done it again with more tests. we could have done different days also. So.
Great job.
I'm Nevada Strandberg, and this is Audrey Bloomquist, and that's Trinity Nelson, and we're from Capitol High School. Our project is on the effects that pets have on particulate matter in homes.
So we chose to study pets because pets are very common indoors across the United States, and 42% of the United States population own dogs, and then 34% of the population own cats. And we also thought that we could help with avoiding future allergies and health problems because allergies such as like pollution and stuff like that is linked to pets, and also the health effects of asthma and bronchitis too.
So our primary question was, how do pets affect particulate matter levels in homes? And our secondary question was, do pets affect small particulate matter more than large particulate matter?
Our hypothesis was that we thought the home with pets would have a much higher particulate matter levels than the home without pets. This was thought because pets let off dandruff, so we thought it might get in the air along with the hair and people breathe it in.
So for our materials, we used a Dialos DC 1700, and we used a monitor charger so the Dialos wouldn't die while we were collecting data. And we used a recording paper to record anything that would have spiked the data, such as cooking or cleaning. And we had a home with pets and a home without.
So first we recorded information about each home. So we recorded the square footage and then the type of heating systems and levels. So the house with pets had a little bit smaller square footage and also used hot water heating system and was 2 floors. And then the home without pets was a little bit bigger and it had a gas forced air system and was 3 floors. And then we started the air monitor in each living room and we plugged it in for the entire time so that we wouldn't have any spikes in the data or gaps in the data. And then we ran the monitor in each home for 48 hours and recorded any times of activity that could have spiked the data.
This is a table of the 24-hour air quality, and as you can tell, it shows the good, moderate, and unhealthy for sensitive groups for the micrograms per meter cubed.
So for our small particle count graph, you can see that there's 2 spikes in the home without pets, and it was from running a washer and a dryer. And then in our home with pets, we have a spike from vacuuming. And then we included the level that good air would be, and then a level that moderate air would be.
So we also added an average small particle count. So as you can see, the home without pets actually had a higher average count than the home with pets. So our maximum small particle counts for the home with pets was 52.55 micrograms per meter cubed. And then in the home without pets, it was 121.09 micrograms per meter cubed. And we found that the spikes in the small particle data lasted only 1.7 hours in the home with pets, and then it lasted 4.2 hours in the home without pets.
So for our conclusion, we came that the results were actually completely opposite than what we originally thought. There was not really an increase in particulate matter from the house with pets, and other activities that could have been like factors that made the spikes in the data. And if we could take further data, we would possibly take more data and try to eliminate factors besides pets. And we could possibly research why the washer, dryer, or vacuum affected the particulate matter so much more.
Do you have any questions?
Yeah. I agree that it seems really surprising that they're opposite than what you thought. Do you think the heating source has to do with the fact that it's gas?
That's what our main, what we thought it would probably be after we took the data, because when we were looking, the forced air system, that's what the home without pets had, so we figured that dust may have collected or something, and when it was turned on or something, it blew out.
With With your washer and dryer, did you check to see if the dryer hose, the exhaust was actually connected? That should be an outside vent, so it shouldn't be increasing particulates.
Yeah, we, like I said, we recorded the data, or like spikes in the data that we found, and then we went back, and the only thing that was those times in those time periods was the washer and dryer. So that's one of our further questions, is maybe studying like why that affected it so much how it did, so.
So I'm Emma Yodis, and this is Ariel Van Dale, and we are from St. Andrew's School, and our teacher is Mrs. Buffington. So we wanted to find out what makes the PM 2.5 levels in our school furnace room so high.
And so, as you can see, this is a chart showing what levels are hazardous of air and what are good for you. And the hazardous is 300 and above. And so we were just, this wasn't for a project at first, this was just testing air purifier filters. And you could see that the levels are super high, they go up to 900, which is 3 times worse than hazardous.
So our hypothesis was that the buildup of PM 2.5 in the furnace caused the poor air quality in the furnace room. And then, so we had a lot of fun doing this, obviously. And so we started by testing the difference of air purifier filters back in November. And so we got the results back, and that was that really big graph where the air quality was up in the 900s. And so we were like, well, we should find out what's causing that. So we tested again, and we still got really high results. So our school board found out, and they cleaned out that closet. So you have the laser. So that's a shark. We found that.
Yeah.
That's from our dissections.
From last year.
Last year. It wasn't in a fridge or anything. It was just chilling in our furnace room. It was really gross. So,
and so this is a picture of before we cleaned the closet, and this was of after. And unfortunately, we weren't able to get a before and after test because our school didn't let us know if they were cleaning it or not. So yeah. And actually, at that time, when they cleaned it, I think it was only a day after the furnace was changed. It was serviced and stuff. So we took another test, and after that, after the furnace was cleaned and the closet was cleaned, and so we realized that there was a fan in there, and we weren't sure if it was on or on for some of the tests. So then we took another test with the fan on and off. We, oh, I love the orange spray. Okay, so we had this orange odor assassin spray that we sprayed in there with the fan on and then off. And then after that, we changed the furnace filters. And then we went and turned on, after we sprayed the orange spray, we went and turned on our school fan, and we started smelling the orange odor assassin spray throughout our high school wing, and which is upstairs, and then the K through second grade wing downstairs.
And so that blue thing right there is our furnace filter. So usually furnace filters are supposed to be like really thick and ridged so that they can like catch all of your particles. Ours is see-through. Like you can't, it literally would catch nothing. So we were thinking maybe it had something to do with our filter.
And so this was after the furnace was serviced and after the closet was cleaned. And as you can see, it got really high, or pretty high spikes and stuff. And this was after, I think this was for 3 or 2 days of testing. And yeah, it's going up and down.
Okay, so then we decided we were going to test the exhaust fan. So the first like flat line right there is when we were just getting our ambient air, and then we took the odor assassin and we sprayed it. That was rough. We sprayed it all in the room, and then right at that top peak, that's where we turned on the fan. And then the fan got rid of all of this this odor, and so there was still some left, but it went back to like the normal levels. So we thought maybe like the fan had a lot to do, whether the fan was on and off, it had a lot to do with how the air quality was. So we tested my furnace and another kid's furnace, and so the first lines on both are just the ambient air, and then those spikes are where we changed our furnace filters, which obviously you can see it got really high. My filter was really old. We hadn't changed it in like 6 months, so it was bad. And then as soon as we changed it, it dropped right back down and it went to like 0. And so we also thought about how the furnace filters, a lot of people think that they just clean the air that's in the furnace, but they also clean the air that's in the room around it and the air that's around the furnace, because it has to intake that air from somewhere.
Okay, so our conclusion was that it was the dust in the room, there was a box of chemicals that if you opened it, it was bad. And we thought it was the furnace, the fan being on and off, and the air intake from the outside were all factors and took part in the air. And so, we were mainly thought it was the air intake from the vent, which was outside, and this is right where our furnace room was in the closet. And so we thought it was just taking in air and blowing it through our school warmer. And a normal furnace thing is supposed to just take in the air, it's supposed to clean it, and then throughout the school it's supposed to push out warm air. And ours was just bringing it straight through from outside. And so, yeah.
That's the end. Those are our resources and our references. Does anyone have any questions? Okay, thanks. Oh, wait, okay.
When you found that shark, how badly was it deteriorated?
Well, it wasn't yet because it was all sealed in. It was still in, but it was still like gross, like it's a shark.
We found a lot of funky things in there.
So yeah, it was fun.
Oh, okay, cool. So, I'm Nathan Lipinski, this is Aaron Kelly, and this is Mary Donnelly, and we're going to be presenting Superior's project, which is radon remediation, which is attempting to reduce radon levels in the basement of our high school. So, before we did this, our teacher downloaded the radon detectors and just decided to put it in the basement for fun to see what the levels were, because, radon is heavier than air, so it collects in basements. His readings were 60 picocuries per liter, which is 15 times higher than the maximum safe level allowed by the EPA, which is extreme, especially because this is a high school basement. So upon learning that, we decided to try to do a mitigation to lower the levels of the radon in the basement to make it a safe environment for the teachers and students. So our next hypothesis is we decided to choose hypothesis 2, that if we implemented mitigation to the basement, there would be a negative net change in radon levels, but it wouldn't get below 4 picocuries per liter just because it was so high. And a lot of times you have to do multiple stages of mitigation to get it to a safe level. So our methods, of course, we measured the radon levels over a 2-month time period. The levels averaged 48.3 picocuries per liter. We then determined the necessary supplies for the experiment, including PVC pipe, a radon fan, a radon barrier, things of that nature. We coordinated with the school's maintenance director, and also, let's see, we got, we also consulted a radon expert to learn about how to mitigate radon safely. And then we constructed a mitigation system with direct help from the radon expert, and then we measured the radon levels to see if there was any change in the levels in the basement. So right here is a little diagram of what we constructed. We found 2 urban crawl spaces with exposed earth, which is where we thought the radon may be originating from, since radon comes from the ground. So what we decided on was to put 1-inch PVC pipe with perforations inside the crawl space and cover it with a layer that radon can't get through. It's a impermeable layer. And then have that go to a positive pressure ventilation fan, which then turns into a 4-inch pipe and then hopefully directs it outside to where it can safely disperse into the atmosphere. So this is our plan. Here's what the crawl space looked like. You can see our radon coming through the ground. Here's our pipe with perforations every 2 feet or so, a 1-inch PVC pipe. We then had a 6 millimeter multi-purpose Durascrim plastic cover so that the radon would be trapped underneath of there. And then we had a turn-on adhesive, which is a 2-sided tape to make a good gas seal so radon couldn't escape and then it'd be able to be piped out safely.
Okay, so in this image, this is basically a picture of what was depicted in the diagram on the last slide. You can see the Durascrim plastic under there, and then it's sealed with that turn-on adhesive to hopefully trap the radon underneath, and then go through the perforated lunge pipe into the fan.
All right, so in this image, what you can't see to the right of this image is the hole students hammered out of the wall in order for the pipe in the picture to be placed where it is.
And this pipe ultimately leads outside. This is a 4-inch PVC pipe.
All right, so in this image, we covered this pipe to keep birds and other animals from plugging the pipe.
And the reason why we put it above the roof is because radon is heavier than air. We wanted to get it above the roof line so it could safely disperse in the atmosphere and not sink down into the basement. Again.
Okay, so that is our radon fan. We have our 1-inch PVC pipe coming in from the crawl spaces, and then we have the 4-inch coming in from the base or from the foundation to create negative pressure, and then the fan is pushing the radon hopefully up through the pipe and out of the school.
And all the students did all this work, so we were actually the ones who constructed this over a 2-week period during our class time. So before the remediation, the average was at 48.3. After remediation is 9.6, which is about 80% decrease in radiation levels. It's not safe, but that's considerable considering we're a bunch of kids who did this. Right here, this is the 2-month period before. We did implementation. You can see it got close to 60. School heating system was turned on. Got a little bit below 40. The reason why it started dropping is because there was a fan, so some of the radon was being brought up from the basement where the heating system wasn't actually dispersed through the school. The levels up above the basement actually went higher as that went down. So after remediation, you can see it kind of hovers around 10, so we're pretty confident that it's going to stay that way, and hopefully further levels of mitigation will get it to a safe point. So in conclusion, the mitigation efforts were very effective, close to 80% of decrease. It's not still at the safe levels, but further mitigation efforts will be able to reduce the safe levels, we hope. So we're thinking about adding another fan to the mitigation system to create more pressure to carry the radon out. Hopefully that might help. Increase the length of the barrier seal. It was part of one of the crawl spaces that we weren't able to seal way far back. And then maybe close up the crawl spaces with sealable doors just in case. But we're fairly confident. Any questions?
No?
Yes?
When the heating system was on, the radon was increased in the main level of the school. What were those levels?
They were hovering around 15 picocuries per liter. That was upstairs. We had another radon detector up there. That's for a different project. But yes, they did go up. And actually, the upstairs levels did go down when we started mitigation in the basement. So, yes.
How old is your building?
Excuse me?
How old is your school building?
1960s, 1970s construction. All right, thank you very much, everybody.
My name is Chris Rossler. This is Austin Goebel and Connor Perry. We were working on an air quality project in our town. So the kind of questions that we had to ask was, does particulate matter fluctuate throughout the day, and at what times? The main times that we focused on were the evening and morning for mainly like joggers or people who don't have a lot of time at home because they're going to be at school or at work. So when will that best time to be outside, morning or night? And the procedure was fairly simple. First thing we did was we asked a question. So then we had to wonder which different locations did we choose. We chose 3 locations just because they're fairly different. All of us actually live in fairly different regions of Hot Springs. I'm more residential. Connor is going to be more of the outside of town, and then Austin lives in the woods of Hot Springs. The data didn't turn out quite as well. And overall, the reason this is going to be considerably higher is Hot Springs had a lot of fires lately, so our particulate matter, being as we're also shaped like a bowl, it kind of stays there. And so up by my house, I got 182.4 registered in the morning and 180.6 in the evening. Connor's house got 184.7 in the morning and 182.3 in the evening. And then near the woods near Hot Springs, over at Austin's house, we got 228.3 in the morning and a 229.7 in the evening. This is the averages after the data was collected over, I think, an hour of time each evening. So I was hoping for like a distinct answer when I monitored this, and there wasn't. Particulate matter did not really fluctuate that much. It was, the 3 locations kind of just showed random data because 2 of the locations actually did have better particulate matter in the morning than the evening, but the other location did not. That's 2 out of the 3, not a trustworthy ratio. Oh dear. Thanks for having us and watching. Are there any questions?
Did you only do a 1 hour for like each morning and evening, or did you do multiple sets of data over different days?
We actually didn't get to use the Dialos machine until this weekend, so we did not actually get to test for long amount of times.
Good afternoon. All right, so my name is Devin Brewer. This is Caleb Coyne, Daniel Liner, and Carson Baker. We did the smog issue. We're from Valley Christian, obviously, and our teacher is Mrs. Glidewell. Go ahead, advance, please. All right, so the big question here, this is kind of why we did it. It kind of revolves around Missoula, where we're based from. So it's actually due to the smog issues in Missoula during the winter, because a lot of people burn. Now there is restrictions in Missoula for burning, and that's kind of why we chose this. So what we wanted to do here is we wanted to make a solution for people, so that they could actually burn Missoula by using a type of wood that produces less particulates that are going to be less harmful to the body. So I'll let one of these other guys take a shot at it here.
Our hypothesis is that the denser woods would produce more particulate matter than the less dense woods because they would burn slower and at a lower temperature. We tested our hypothesis by burning 5 different types of wood: fir, mahogany, poplar, pine, and oak.
As my partner Devin mentioned, my name is Carson Baker, and I'll be doing the procedure. We started out by finding 2 samples of 5 different types of wood: mahogany, fir, oak, poplar, and pine. Our density ranged from our densest wood, which was mahogany, to poplar and pine, which were our least dense woods. After that, what we did is we made sure the volume was the same, so we cut the wood down so that it was all the same. After that, we placed the wood in a dry room for about a month to keep the moisture the same. Once the wood had dried, what we did is we took a planer and shaved off small pieces of the wood to help to create tinder so that the fire would burn easier. Also, we took a hatchet and split the wood into small pieces, again to give the fire the best chance of burning. After that, what we did is we measured out a teaspoon of lighter fluid and started the fire. Once the fire was started, what we did is we waited for a minute for the wood to burn, and then we measured the particulate matter. Caleb is going to do procedure. So the tinder what I was talking about is the tinder is in my hand. So, because the wood was just in a large block, so if you just threw that on, it wouldn't burn. So I'll pass it on to Caleb.
So basically, as you people can see, the red and blue represent small and large particles. There isn't really a change in any of it at all. until pine, but other than that, yeah.
You good?
Didn't live. There was no significant change at all whatsoever until pine. Pine had a smaller large particles, but didn't change the number of small particles. So basically nothing happened.
Yeah. Okay, then. You ask if you have any questions.
Questions?
Wow. Yes, you way back there. I can't hear you. Yeah, we think so. So the wood was actually less dense, and it actually burned quicker. So we think that the density of the wood has to do with the particulates that it will put off, emit. Any other questions here? Yeah, you white shirt fella. Yeah, so actually what we did is we cut all the pieces down, and then we would have started the fire, and we would have waited a minute. And then we would have lifted, because this was in a enclosed, it was in a, what are those things called? A grill. That's what it is. Yeah. So it was in a grill, and so what we did is then we lifted the lid and we measured it, and then we let it air out. So then all the emits would actually be lifted up into the atmosphere, and then we would restart it with the same test and the same thing, and then we wait for a little while longer and start a new type of wood. So we gave some time. Is that what you're asking?
I was wondering how much time it may be to let the fire burn while we're taking the measurements.
Oh, yeah, the fire only burned for a minute, and then we lifted the lid. So, does that answer now? Yeah, please.
Can you go back to the graph?
Yeah.
It says like pine 1 and pine 2. Is that just two different trials?
Yeah, so there's just two different trials of pine, both same size, both sat out for the same amount of time. The tree would have been cut down at the exact same time as well, so the pine would have been the exact same as the other pine.
Because it looks like the poplar, between the two trials of poplar, they're almost double for the large particle, from like 3 to almost 6. So maybe more trials could have.
Yeah, more trials could have potentially happened. That would have made our thing better. Yeah. Yes, please.
You guys were trying to find out about the Missoula Valley, and so why do you pick this particular type of wood to burn?
It was just handy to us.
Do you think most people in Missoula Valley are mahogany?
No, they wouldn't. No, that's a little too expensive. No, yeah. No, we just did that to test it out, because it's a higher density wood. Yeah, yep.
So what percentage of households in Missoula use wood for heat?
I don't know a percentage. I know not very many do, because there's a
ban.
A ban on burning in Missoula unless your house was built before the 1970s, I think is what it is. So not many houses in Missoula can actually burn, but down the Bitterroot, once you're out of Missoula County, burning in a wood stove is actually legal. So, but in actual Missoula, I don't know. Yeah, Joey?
What's the percentage where they either pellet or they do what percentage of the wood stove?
Yeah, lots of pellet, yeah. I don't know. Do you guys know?
No. No.
Yeah.
All right, guys. Good job.
Thank you.
So I'm Jessica Monahan, and this is Ashley Lou and Ashley Dew.
and we're from Big Sky High School. And our teachers are Mr. Jones and Mr. Ferder, and we did our air quality experiment at Miss Mo Gymnastics. So this is kind of the layout of the gym. Sorry for the quality of the picture. To about, like, right here would be the office to this picture, and then right through there is the little gym, which is pictured right there. And
Oh, wait. Was there?
no, that's good.
Oh, okay. My bad. Okay.
So the main question we had for experiment was, does the air quality of the gym differ at different levels of activity? And our purpose, like the purpose we had, was to observe air quality changes in a gymnastics gym during periods of high activity and low activity for several days and nights. So the background. Chalk or magnesium carbonate is commonly used in gymnastics, rock climbing, and weightlifting. In gymnastics, high activity is when the higher level gymnastics are practicing, and low activity times are when the lower level gymnasts and preschool classes are happening. Gymnasts use chalk for a variety of things: beam, vault, and most often bars. It is applied to hands and occasionally the feet to remove perspiration and reduce slipping. It is also applied to the bars for the same reason. So they are easier to grip. There are chalk buckets that contain the chalk gymnasts use. Poor air quality can be potentially harmful. It can cause dryness and irritation of the eyes, nose, throat, and skin. And it can also cause headaches, fatigue, shortness of breath, coughing, dizziness, and oh, that's weird. Okay, anyway. It can be especially harmful to those with previous respiratory issues. As for the gym chalk, since it's inhaled in like little increments or little quantities, it doesn't really have the chance to become any issue for people with but however, like for people with respiratory issues, it may be harder for them to breathe. Okay.
Okay, so our hypothesis was as the activity levels in the gym increase, so would the particulate levels.
Yeah.
Keep going. So the independent variable was the time and area that we put the PM samplers in, and the dependent was the small particulate levels in the air, and the controlled variable was the PM monitor in the office, which was away from all activity. So what we did was we took 2 of the Dialos PM samplers and we put one in the gym near the bar area, and then which would range from high to low activity, and then one in the office which had little to no activity. And we put them on, I have some pictures. So right there right in there was where we put it in the office. And so right kind of past, right here was which is right about there, we put it in the gym, which was pretty near the bars, and then we left them on and we turned them on, and then left them on for a few days.
Okay, so this is a graph of our results. The red line shows the activity in the office, and the blue line shows the activities in the gym. And the graph starts at Friday around 4 o'clock, and you can see it spike up to 8 o'clock. And that's about when the higher level gymnasts and the lower level gymnasts practice. The high level gymnasts practice the most rigorously and also with chalk, and they also practice for 4 hours. And the lower level gymnasts only practice for 1 or 2 hours and don't use as much chalk. After the peak, it starts to decrease as people leave the gym and the gym is closed off for night and allowing the particles or particulates to settle. Then around the next day at approximately 8 a.m. or 9 a.m., beginner level gymnasts start coming in, and the activity level, or the particulate levels aren't as high because the workout isn't as rigorous as the day before. However, there's still activity in the gym, and then it starts to settle again as the gym is cleared and the activity, there's no activity in the gym. And then Sunday is when the office level, when our office data runs out. So, however, the gym data tells us that when around 12 o'clock, activities or levels start spiking again, and that's when gymnasts start coming in and the higher level gymnasts start practicing again, and they start to settle at around 8. Okay. So in conclusion, the particulate levels and the activity levels have a direct correlation. As activity levels increase in the gym, so do the particulate levels in the air. And this is most likely because of the use of the chalk in the gym. And also, there may be a little bit of bias because the one of the PM samplers that was in the gym was very close to the office, or very close to the bars where most chalk is used. And the levels in the office also correspond with the levels in the gym, although not as drastically because the office was closed off, but all the air is still circulating, so there's still air that's moving. And yeah, okay, thanks, well, some improvements to this would be to not place the PM sampler so close to the bars as to cause a bias. And yeah, so thanks to our teachers for helping us, and thanks to Mismo Gymnastics for letting us use this gym. Yay, science. Questions?
Oh, yes, sir.
So what do you think could be done at Mismo to reduce the particulates during periods of high use?
So I guess if there are different filtration systems that could just reduce the chalk levels in the air, that would bring down the particulate levels quite a bit.
And also like maybe like different placement of the vents. So like if you see like in our results, like we put our PM sampler next to the bars, and so it was next to the bars, so hence that shows that the more chalk is used in that area in general. And so if like maybe one of the venting systems was like placed above that area, then the air quality probably would be better in there. Anyone else?
Sure, I have another question then. Do they vacuum on a daily basis to vacuum up the chalk that settles down?
I think it might be weekly that they vacuum, so that might take up some of the chalk, but not enough to decrease the levels significantly.
Any more questions? Okay, thank you.
Thank you.
All right, hello, I'm Ben Erickson. This is Kaylee Evans, and we're from Corvallis High School. Our experiment was on the effect of the presence of water on air quality.
Just to begin, I think it is important to know that air quality can be affected by rain. When it rains, the rain traps the particulate matter in the air and brings it to the ground. Also, the rain dampens the ground, which prevents dust and particulate matter from being kicked up on the roads by cars and even just people walking around. These two graphs are from the Montana Air Quality website. They show a couple days when it rained. As you can see in the first graph, August 12th, the air quality was a little bit worse at the beginning of the day until it began to rain, and it dropped. And then it continued to rain throughout the next day, and the air quality stayed lower.
So this information begs the question, does a body of water affect air quality positively like rain does? So we were wondering, because rain is obviously made of water, does a standing body of water like the Bitterroot River affect air quality in the same way rain does? So our hypothesis was, if particulate matter is in the air near a source of water, like the Bitterroot River, then the water will reduce the amount of particulate matter. So our experiment first was we recorded in an area near a river for an hour with the dilith pump. Then for our control, we recorded away from the river in a drier area for an hour with the same machine, and we recorded the data.
Okay, our controls included the weather, which was dry and warm, and the temperature was the same. The date, we did it on the same day. The relative time of day, we recorded that information in the afternoon. We tried to keep the distance from a major road and a dirt road about the same. Each of the areas was pretty far away from a highway, yet each of them had one dirt road by it, and about 3 or 4 cars came down each dirt road when we were testing. The relative altitude was approximately the same, and we recorded each for 1 hour.
So this is the area where we tested near the river, and I'd like to point out that this photo was taken on a different day. It was perfectly clear on the day where we were recording.
And this is a photo without the river that we're testing in. It was also taken on a different day. So the results, as you can see, the river had a worse particle count than the place without the river. It was approximately 2 micrograms per meter cubed of PM 2.5 worse than the area with the river. Yeah. So for our conclusion, I would like to restate our question, which was, does a body of water affect air quality positively like rain does? The answer would be no. The air quality was slightly better in the climate without the river than the climate with the river.
So like all experiments, including our own, there are some possible improvements. If we were to run this experiment again with more time, we might test more than one day to see if it was just one particular day, the day we tested on, that was affecting the air quality in the 2 places like this. We'd also test more than one location for each climate. Was it particularly just these 2 places that were affected like this, or was it consistent for everywhere? And we'd also like to test multiple times of day. We tested in the afternoon around 4 to 5 p.m. And if we had the Dilus pump for longer, we'd like to test maybe in the morning to see if the air quality is affected differently by the river at different times of day. So these are our sources. This is where we got the information about how rain affects air quality and how it collects dust from the air.
Questions?
Cassie?
Why do you believe the river had worse air quality than the dry land?
So we thought about this for a while, and like we thought at the beginning with our hypothesis, we figured that it would actually help the air quality, and looking back on it now, we figured that the river might have kicked up more dust being that it's moving. You know, a running body of water has the rapids and everything might kick up more dust, and maybe that affected the air quality. But if you look back on the graphs, there was only 2 micrograms per cubic meter difference. So it really wasn't a huge difference either way. And so yeah, any other questions? All right, thank you.
All right. So that was the last one. So I'd like to call the poster judges down here. So we're going to give away the thank yous to the poster judges and our presentation judges. All right. So because we had a record number of posters this year, we had to have a record number of poster judges. So we started out with, I think, 5, and then quickly realized we needed to recruit a whole bunch more. So I'll introduce the original poster judges. So Carolyn Hester, Joanna Cardinger, Dr. Aaron Simmons, Emily Weiler, and I'll introduce Emily Weiler again because I forgot her last year. So Emily Weiler, Andrew Rank, Jenny Kay, Jed Sirini. All right, and then we can do double claps for our 3 folks that stepped in at the last second. So Kevin Trout, Desiree Ware, Holly Ferris. Is Holly in here?
Holly's back here.
So Holly is a teacher at Hamilton High School, so thank you very much, Holly. We appreciate it. So your poster judges. You want pictures, Naomi?
Yeah, I do.
Okay.
Okay, real quick. In the screen, is there anything can you turn off the projectors? You guys all have to get squishy. Feel the poster, Judge Claude. Okay, ready? Can you turn off the Okay. 1, 2, 3. And,
Okay. Thanks, guys.
Thank you, guys.
So now we're going to introduce the presentation. So Ben Schmidt, Missoula City County Health Department. Steve Gaskell, Health and Human Performance at the University of Montana. Bill Grana, Division of Biological Sciences here at the University of Montana. Mary French, Center for Environmental Sciences here at the University of Montana. And then last but not least, Ronnie Flannery from the American Lung Association. Before we start handing out the awards, I did want to thank a couple of groups. So one is the Montana Department of Environmental Quality, especially Bonnie Rouse, who gives us money every year to help host the symposium. So Bonnie, can you please stand up? And then the symposium is also funded from the National Institute of Health Science Education Partnership Award. So now that we've said that, we would like for all the teachers to come down here, please.
So I'm going to say your name and come and get an award from Earl. Dave Jones. Rob Hamill from Corvallis. Mary Rampy. Logan Mannix. Noel Gladwell.
definitely a hard decision. We had a lot of awesome posters, and you all did a super great job. Okay, for third place, the name of the poster is Elevation, Location, and Radon. Kelsey McEnny, Megan Sweeney, Victor LaMeza, Alex Simmons from Big Sky. Come on down.
Will you send them?
Congratulations. And you want to stand up here?
If you guys would just stand in front of the screen, I can get a picture of you. Okay. 1, 2, 3. Smile. Perfect. Thank you.
Okay, for second place, the name of the poster, Wood Types and Their Emission of PM 2.5, Anders Watt, Corvallis.
Will you hold up your envelope so we remember what? Perfect. Thank you. Perfect. Okay.
Okay, for the first prize for the poster competition, the name of the poster is Comparing the Performance of HEPA and Activated Carbon Filters in a Standard Air Purifier as measured by PM 2.5, Christopher Silka from St. Andrew's School.
Sorry, I have it. I didn't mean to have it. Will you hold the envelope so I can see what it says? There we go. Perfect. Thank you. So I just wanted to say, Tony accidentally said something a little wrong. In the past, the gift cards used to be to the UN bookstore, which is what he said. But actually, these are like Visa cards, so you can use them anywhere. So if you're in a group and you win one of these, there is only one Visa card in the thing. You guys have to figure out a way to divvy it up. But anyway, they are Visa cards that can be used anywhere you want to spend them. Or maybe they're MasterCard, whatever.
Okay, guys, nice job on the oral presentations. Let me go through it. Third place from Superior High School, Rampant Radon Remediation. Nathan Lipinski, Nick Barberis, Aaron Kelly, and Mary Donnelly. Come on down.
Okay, and then if you guys can. Oh wait, no, we're way too zoomed in. Okay, 1, 2, 3, happy! Perfect, thank you.
Okay, second place from Highland High School, bioremediation of air pollution due to wildfires, Raylyn Davis.
Thank you so much. Perfect.
Nice job. Last one of the day, guys. First place, radon levels in Missoula soil from Big Sky High School. Good job. Nice job, Jeff.
Okay, 1, 2, 3, smile. Perfect, thank you.